In the last video, we looked at an example related to machine 1. Now we're going to look at an example relating to machine 2. We want to know what percent of pop bottles will be filled at least 12.28 ounces on machine 2. Okay, remember we were previously told that the volume of pop bottles coming off of machine 2 is normally distributed. So it is going to fall according to that particular spread of data. However, I cannot use the exact same normal curve for machine 2 as I did in machine 1. Think about why. Remember the mean of machine 2 was 12? So the mean goes right in the middle. Here it is at 12. And I know that 34% of the data is going to fall within one standard deviation above the mean. But for machine 2, remember what the standard deviation was. It was not the same as machine 1. So that means when I go to label my x-axis, those points are going to be different. I'm not adding on 1.41 each time to go to the right or subtracting 1.41 each time. I'm actually working with this 0.14. So the first point that I mark is 12.14. That comes from adding on the standard deviation once. When I add the standard deviation on twice, I get 12.28. And when I add it on a third time, I get 12.42. Okay, these percentages though are the same because in normally distributed data, this is exactly how the data falls. When I go to label the x-axis to the left of the mean, I will be subtracting 0.14. So that gives me 11.86 here, 11.72 here, and 11.48 here. Again, that spread of the data is the same whether it was machine 1 or machine 2 in terms of percentages, because any data that's normally distributed has that percentage distribution. What's changed are the points along the x-axis. Okay, now to answer the question, what percent of pop bottles will be filled at least 12.28 ounces? 12.28 is the data value in question. Perhaps the company realized that though the bottles that are made to hold 12 ounces have some room at the top, anything beyond about 0.3 or 0.3 of an ounce is going to start to cause the bottles to overflow. And that's bad news for the company because they're going to have a mess they have to clean up and they're going to have product that has been wasted. So perhaps they're interested in what percent of pop bottles coming off of machine 2 are going to be overflowing. All right, so 12.28 is our data value in question. There it is. This time it says what percent of pop bottles would be filled at least. You have to understand what at least means. Okay? Before, in machine 1, it said less than, and that was pretty easy. We knew to be to the left. But this time it's using the term at least. Well, at least means we can be here or higher. So we want to know what percent of pop bottles will be at this limit of 12.28 or higher. Well, as you can see from the graph, it's 2.35%. So about 2% of the time, the company is going to have overflow from machine 2, meaning their pop bottles are going to overflow and they're going to have that wasted product and that mess. Okay. In the next video, we're going to look at one last example relating to another set of data that is normally distributed. So tune into that one for one final example of working with normally distributed data on the normal curve.